There. Hi, welcome. Sorry about that. It is a Monday morning and my microphone was muted. Ah, I don't know. Anyway, I was saying uh, it is in northern Michigan right now, kind of snowing, raining. I don't think I would want to go outside if I could, but given the current state of the country, nobody's really going anywhere anyway. So, with that in mind, let's talk shapes. Because I love building things, but sometimes when I build things, they just fall down. And let me give you an example of what I mean. I've got some, you could do this with Legos, Vex parts. You could do this with Connects. Heck, you could even do this with some nails and lumber if you really wanted to. But to show you what I mean, sometimes I'm building something and I'm putting in these little pins, and then I'm going to connect another part, and I'm like, it doesn't stay straight. So I try to build, and then it just goes bloop, and it tips over, and it's like, which is great, I guess, if we want to make a helicopter. So then, of course, you could add more plastic and more parts and more nails and more pins, and eventually you make a rectangle of some sort, and we try to build this thing and it tips over, which, well, is certainly a cool looking fidget spinner, but not really effective if you're trying to build a skyscraper. However, while we got this cool thing, let me switch the camera angle here. Oop, there we go. Can you tell me what shape this is right now? There. It's not a square. It's a rectangle. And the rule of a rectangle is that it has to have 1, 2, 3, 4 corners and 4 sides. The corners are called vertices. And each corner has to be 90 degrees. Now, it's not a rectangle anymore, is it? It would be called a parallelogram, meaning that two sides are parallel to each other. But the angle, you can see we can do some vertical, the angles are definitely not 90 degrees. Another fun way to say that is they're not right. I cracked myself up. Not a right angle. Because it's, well, not 90. It's not because it's wrong. I mean, in math, wrong? I don't know. Anyway, but sometimes we build stuff and we're like, I want it to stay up. So let me introduce you to a really cool idea. Ready for it? Right? Right triangles. Now, that's not that a triangle that's not a right triangle would be a wrong, because we don't really have wrong triangles. It just might not be the right use. So a right triangle is something very specific. It is any type of, look, I got graph paper. It is any type of triangle that is actually has a right angle in it. So, for example, I wonder how this marker works. I haven't tested it out. Let's see. This Oh, it's not nearly bold enough. All right, let's try this one. This is an example of a right triangle. Let's zoom in on that guy for you. Beautiful, because this right here is a 90-degree angle. Now, I don't know what the other two are, and that's what makes sometimes building difficult. Let me show you what I mean. Okay, so we're going to go back to this guy here. Oh, got to zoom out. Here we go. Zooming out. Let me show you what I mean. If we put a couple of pins just somewhere, I don't know where, maybe there and there. Okay, so I added 2 pins, and I'm going to take another part, and I want to try to keep this a rectangle, and you put in your first part, and then you come over here, and you're like, well, what if I put a hole there? You can look at this, and you can say, wait a second, that's not quite a rectangle anymore. It's really subtle. And then you can say, well, I can fix that. So I'm going to go to here. And you say, wait a second, that's definitely not a rectangle either. But the thing I guess I want to show you about this is, notice, it doesn't change its shape. Once we've added that triangle, whatever the rectangle was, well, it's not a rectangle. It's now a parallelogram. It's not, well, I mean, it's cool, and it's not going to fall over. It's rigid, but it's certainly not a rectangle, which means if I'm trying to build a skyscraper on nice rectangles, it's not quite going to work. So let's see if we can get that back. There we go. Okay. So the problem with a lot of our building sets is that, we can try this one, and we can line it up with our paper as best we can, and you can still see that it's close, but it's not quite a right angle. There, I'll level it out for you. There. See that bottom? It's still not quite flat. So here's the cool thing about these right triangles. There's one special right triangle which works out really, really well in the world of, say, Legos or even I guess if you're building Minecraft online, I suppose that would work. But anytime you have sort of a fixed size and you can't do like parts of a block. I mean, can you really imagine building 1 3/4 of a Lego brick? That just doesn't make any sense. So there's one particular triangle called a 3, 4, 5. Not hard to remember. It's a 3, 4, 5. Now, this is a very special triangle because what it says on this 3, 4, 5 triangle is that there is a triangle which would look something like that. And the 3, 4, 5, what that says is that this angle right here is going to be 90 if this right here, the short side, is a 3 Lego bricks, 3 pitch, 3 inches, 3 feet, whatever you want. But then the medium length, which would be this one over here, is a 4. And then this one over here must be a 5. You're scratching your head. You don't believe me. You look skeptical. I'm not sure why you're skeptical. So let's go back to our idea here. And let me just pull these pins out and let's see. Okay, so I've got this thing and I want to make it stay up. So according to that, I need 3 holes from the bottom. So let's go ahead and count. Here we go. So I need 3 holes from the bottom. I need a good pointer. Here we go, pointer. So I start here and I go 1, 2, 3. Okay, so I need to put a pin right there, like that. And then I need to start at the bottom and I got to go 4. So I'm going to go 1, wait, that's 0. So we got to count 1, 2, 3, 4. So I need to put a pin right here. Okay, so I'm going to 1, 2, 3, 4. So I put a pin right here. And now, according to 3, 4, 5, are you ready for this? There should be a beam that is 5 long that would go exactly from here to here so that this is perfect. Okay, let's check it out. Let's try it. I don't know. We'll use, here's one. Let's see. OMG. Now we got to count these. We've got, so we start here, we go 1, 2, 3, 4, 5, which means that this right here is a perfect rectangle. And check it out, it's stuck. Just by adding that one little piece. I mean, of course, it's not quite the right length. But what if I wanted to make it a little closer? Well, I can take this same 3, 4, 5 and watch what I can do. It's like magic. What happens if I say multiply this one times 2? I'm going to get a 6. And then what happens if I multiply this one times 2? I'm going to get an 8. So I've got a 6, got an 8. And then what happens if I multiply the 5 times 2? I'm going to get a 10. What? I mean, this is just crazy. This is a lot of math for a Monday. So, according to these calculations, if we have the short side equal to 6 and the medium side equal to 8, then the long side, otherwise nicknamed the hypotenuse, is going to be 10. Let's check it out. Okay, let's flip it back. Here we go. I'm going to pop out these pins. Let's see, because this is just like, I don't even know. Here we go. Let's count from our corner. We need a 6. So we go, here's where we're starting. We'll jump 1 section, 2 sections, 3 sections, 4 sections, 5 sections, 6 sections. Right there. I need a pin. Bloop. Okay, now we're going to go up. Here we go. 1 section, 2 sections, 3 sections, 4 sections, 5, 6, 7, 8. 8 sections. Okay, so we need a pin up there. All right. Now, I don't even know if this piece is long enough. Let's check. How many is this? We can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, it says that it's a 10. But when I actually count it, I don't think it's quite going to reach, because you got to count in how many jumps can you make. So a 10 pitch is only actually 9 sections long. So I've got nowhere to connect. I can't connect it on that 10th hole. See, that 10th hole is missing. So I need a longer piece of plastic. All right, I'm going to reach down here to my magical pile of parts. That's the same length. That's definitely not the piece that I want. know what we're going to do? We're going to make a 10. So we decided already. Wait, I'm holding it in my hand. Where did this come from? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't even know where this came from. Huh. But yet here it is. The perfect part. Okay, here we go. We're going to put this one right here. We're going to snap it down. And now we're going to figure out where the other one goes. Ready? Starting here, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to put it right through here. So let's go and stick it right through that second to last hole. And whoa. Wowzers. Look at that. It's almost like magic. 3, 4, 5. Crazy. Now, you might be wondering if that's the same thing as the other one that you might have heard about, which is a 30, 60, 90 triangle, also a very special right triangle. And the answer would be no. These are not the same. A 30, 60, 90 triangle says that the angles in here would be 30, 60, and 90. And these on a 3, 4, 5 are not 30, 60, 90. This one down here, yeah, that one is a 90, absolutely. But this one over here is actually closer to like 36. I wrote some notes about it earlier today. Yep, I was right. It's actually about, this one over here is actually about 36 degrees. And this one up here is actually about like 52 degrees or 53 degrees. But it's pretty cool because, I mean, it makes for a very rigid structure. And I don't have to bend any plastic. I mean, I've seen a lot of kids try to make things fit that don't fit anyway. That's what I got for today. So how are you doing? Now, your challenge, if you choose to accept it, is to go outside. Well, I'm not going to go outside right now because it's kind of snowing, slushing. So your challenge, though, when it gets nicer, is to go outside, maintain your social distance, and look. I want you to look for triangles. Now, if you would like to go and look for a isosceles triangle, you can. We didn't talk about that one today. Maybe we'll talk about that tomorrow. I don't know. We'll see. I had a dream about right triangles last night, which is why we're talking about right triangles. But I want you to go look for right triangles, which means that right there is 90 degrees, that little corner, or it's called a right angle. That's it. It's a right angle, not to be confused with a right angel. Very different. So see what you can find. Now, so that's your today's task. You go see what you can find. I bet they're out there. And you might not even know it, but those right triangles are what is holding up your world. Believe it or not, without those nice right triangles, everything around us just kind of comes crumbling down. So we like right triangles. But one more thing before I sign off for today. Oh my goodness. So many things. Last Friday, I sent you out with a homework assignment. I wanted you to go out and, again, get outside and go and look at something growing. I want you to look at something growing, and I want you to measure it. And I want you to do it over a couple of days. So if you did do it, I did it. I went outside in my front yard. There's a tree. There's a really big tree with more sticks right now than anything else. But down at the base of that tree was a little itty bitty flower. I think it's a flower. I mean, it doesn't really look like anything right now, so maybe not. But I measured it. I measured it with my millimeter ruler. My millimeter ruler. That's right. I pulled out my ruler and I measured that thing. And do you know what I measured on Friday? I went out and I measured it, and it said, are you ready for this? 11 millimeters. That's right. On Friday, it was 11 millimeters. So then you know what I did? I went out on Saturday and I measured it again. And do you know what I measured on Saturday? Not 11 millimeters. It got bigger. It was 13 millimeters. I mean, now if you just sit there and watch it, you just sit there and watch this stuff and it looks like nothing's changing. But it did. It changed by 2 millimeters. And then I went and measured it again on Sunday. On Sunday. And do you know what it was on Sunday? It wasn't 11. It wasn't 13. And if you're seeing a pattern, you're saying, I bet it was 15. It wasn't 15. It was 16. Go figure. Go figure. That was crazy. I loved it. I was looking, and then on Sunday, it was a full 16 millimeters tall. I was like, what? This is crazy. So I haven't made it out there today to go and measure my little, maybe it's a tulip. Maybe. I don't know what kind of flower it is. It's something that's been planted by the tree in our front yard. We'll go find out. And once it does actually pop up, I will report back on what kind of flower that is. So today, go outside, take a ruler with you. Take a ruler because it makes investigating so much more fun. So look for your triangles, measure your growing springtime excitement, and I will see you right back here tomorrow. Have a wonderful, wonderful rest of your day. Let's see if I can figure out how to turn this thing off now. Let's push this button. Well, that didn't quite do it. Let's check this one. Maybe if I hit, oh, there we go. Maybe stop streaming.